right, well, thank you, everyone. It's great to be here. And thank you, Lisa, for organizing such a great event, and Robert. It's my pleasure to be here with Medya. He and I have been talking about this with some anticipation in the sense that we both have a lot of experience either from customers or at time at Google or at Medya at Target, and we were talking about what are all the mistakes you can make. So in some ways, this is motivated by the fact that we have these great new schedulers, this immutable style infrastructure that we're all striving towards and wanting to be cloud native. At the same time, we can all make simple mistakes, just like anything else in life, that really kind of ruin it for the rest of us. So in some ways, I want to keep this a little bit more of a shared dialogue. I know I've been accused at times of drilling all the way into the weeds, so I'll keep this hopefully at a high level. But we'll stay afterwards just for some more conversation as much as you guys would like. So please consider this a conversation, although we have the mics. But we'll ask you to raise your hands, share your thoughts, and in some ways, think of this as an interactive family feud. So the topic really is how not to, or as one of my friends would say, you're doing it wrong. So how not to run with Kubernetes. And so there'll be some examples from my experience, some from Medya's, and we'll talk about it both from the IT as well as the developer's point of view. And so you'll see us trade off back and forth on that. And this actually represents probably my college experience. Hopefully it's not here today, in the sense that please ask questions. I was told to make sure I run on time, which I'll do. But at times, you know, the more that we can share, the better. Because in some ways, this is a whole new ecosystem. The more that we are interacting, the more we're getting to the right answer. And the best part about where we are today is the best things are happening with customers in mind. So I learn as much from my customers, and I'll share some of the more anonymized results here. So please keep it lively for us. With that, I'll just briefly introduce myself, and I'll turn it over to Medya. My name is Eric. I am responsible for product management at a company called Portworx. I will demonstrate some things from Portworx at the end, but most of this is just at some fundamental level about cloud native Kubernetes and some experiences that we've seen working with customers, both my time here at Portworx and my time prior. With that, I'd be very happy to introduce Medya.
Hi guys, my name is Medya, and today I'm going to teach you how to take down a Kubernetes cluster. And I am a senior SRE at Google, and I'll be happy to share with you all the things I've seen that takes down a Kubernetes cluster. What's the next? Oh, actually, so I started my Kubernetes journey not at Google, but at Target. And this is the Black Friday at Target. This is actually a real picture, not the left part, but the right part. If you know that the real reason that we have cloud is the retail, like Amazon came up with cloud because of Black Friday. Black Friday is extremely important for all the retailers. Like you have no idea how much of the revenue of all these retail stores, all of them, they make on Black Friday. It's extremely important. So we prepare really well for Black Friday at Target. I assume everybody knows a little bit about Kubernetes here. Does anybody think they don't know anything about Kubernetes? Show of hands. Who here knows something about Kubernetes? Okay, I was just testing if your hands work. So Kubernetes, they say it's like a Tetris game. So if you remember the Tetris game, if you ever played it, it's like a bunch of shapes coming at you, and you're supposed to fit them in those spaces in the best possible way. A lot of people think Kubernetes is like magic. It's just like all it does is schedules your stuff in the best place. You give it a container, it says, oh, there's a bunch of computers. This one is the best one to run on it. And when it doesn't work, it will reschedule it and another thing. That's the basics of Kubernetes. People think Kubernetes is about containers. That's not correct. You can actually run VMs with Kubernetes. You can make Kubernetes schedule VMs. So it can schedule anything. It happens to be scheduling containers. At Target, when we started Kubernetes, Target has thousands of developers, and everybody was excited to be on Kubernetes, a new shiny thing, but they were not ready to be on it. So let's play this video. Let's see what is this one. Oops. Okay, this is actually Houston, Texas, a Target store. If you look at this during the flood, there's something going right in this store. And it's actually because a lot of places were affected by the disaster, natural disaster, but this one is actually, a lot of things are working. You can see the lights are working, the systems were all working, the emergency systems were all working, and nobody got electrified. So this is the kind of plan we wanted to have for our Kubernetes cluster. In a BlackBerry, in a disaster mode, we wanted to be operating without electrifying people or keep the lights on. So that was the mentality. And I'm going to share with you some of those things that we did. Let's go next.
Thank you, Medya.
I don't think it goes next with this. You can
okay.
manually.
Got it.
Yeah.
So I think Lisa and I were debating if anyone still knows Family Feud and who the host is. I think it's Steve Harvey. But at the same time, if we were to survey people and survey from an IT and a developer's perspective, this part I'd like some participation. If we were to say what's the first thing or most common thing that people cite as one way to ruin their Kubernetes cluster, somebody shout out an answer. I heard etcd. What's that? Load balancer. I get that, the ingress controller, and we can do demos with it later. Any others? So I'll give a different answer, and this is all non-scientific in the sense that more and more of my examples will be more just to illustrate the common points, right? So as much as I want to say that it's etcd, it's things like making sure that you understand the upgrade policy, I'll describe a different one, which is that in general, I'll give the most basic, is putting all your resources in one basket, or in some ways creating a single point of failure. etcd could be an illustration of that in terms of how many times etcd is being replicated at the same time. And the other one that I see a lot of times, and it's probably the most illustrated in cloud, is how to handle the SLA. So as you know, public clouds have SLAs that are written for 2 availability zones. So the onus is really on the user to say, I'm going to deploy in one AZ and in the other. But the moment I have certain applications that become sticky, it becomes non-trivial. Right, so deploying your eggs so that not all the eggs are in the single basket, that if there's a brownout or the availability zone drops, that you can actually run your apps in the other AZ. That becomes incredibly important. And the more interesting examples that I've seen take this point and just re-examine them in different environments. So on-prem, we've seen this with customers who want to run across racks. That becomes incredibly important. And even in the fact of hypervisors. So VMware, OpenStack, every KVM, they want to make sure that they don't put all their applications, all their data into a single hypervisor, because that becomes a single point of failure. So in some ways, I wanted to start with a trivial, but illustrate the fact that it becomes important to your design that, as Medya says, you could schedule anything, but how do you schedule it so that you have the availability and the reliability that you're truly desiring, right? Because everything else comes after you can ensure that your applications are up. And this next one, this is not the illustration, but it's more of an interactive quiz, is if I was to ask who is the best backup quarterback to reach the Super Bowl, and this is actually, I'm going to cite a non-scientific source called ranking.com, so you could verify it later. Who would say it's Nick Foles? Okay, I only have 2. Who would say it's Kurt Warner? And I'm going in reverse. I only have 4. And what about Tom Brady? I have about 7. Okay, so
who doesn't care?
We could choose different examples if you'd like, but actually in this example, it was actually Nick Foles. So maybe there's a recency bias. I'll say that in my opinion, it's not important to me because I came from Illinois and all our quarterbacks have been bad. So I'm very tired of seeing other quarterback backups do much better than any Illinois starting quarterback. But the other one I'll say is that backup point is more to say, what is your backup strategy? And so if you look through some of the examples, and all of us have this personal history, and you guys can share it here, is that it could be configuration, it could be data. I don't want to scope it to a certain problem statement. But not having a backup plan and sticking to it. And the example that I thought was most illustrative, especially as a father of 3, is my kids love Toy Story, and Pixar at some point almost lost all of its Toy Story rendering data while that movie was still being made because someone did an RM star. Right. I don't know if it was an RM-RF, but it was actually deleting. And you could say, well, did they have backups? They had backups, but actually the backups had not run in a month. And this video, which we can share later, they go through the whole story of the people who were interacting. And what ended up happening is the backups hadn't run in a month. Somebody happened to have it at home. But the whole point here is you need a backup strategy because at any point, I need a way to recover both the data, the configuration, and that becomes something that we have to do on the beginning, right? It's either we learn it painfully or share those lessons collectively, or we have to go through something like this. And the third one, and then I want to in some ways start to expand the topic, it becomes, I think that the greatest challenge that we're all facing right now is that there's a mismatch in expectations. When I look at applications of what people want to get to, we get very fancy at the top level, and we can start to describe canary-style deployments. How do I take an application, sample it, and we did this when I was at App Engine. Everyone does this, is very common on AWS as well, is that I will have a set of machines and I can start to expose either pods or some set, using Istio, some set of applications and canary test them. I could do it with blue-green, and it's just deploying more of a bulk set. So I start to get very sophisticated and numerical when I look at applications. But oftentimes on the infrastructure, the analogy, and this is me bastardizing 3 analogies now, the analogy that people are using is it's almost like they're burning the ships, in the sense that you talk about we're going to take this strategy, we're committing to this strategy. And some of this is born out of the more past legacies that we all come from, because in some ways we're trying to get to a better place. But we really should be expecting more from infrastructure, and at the end I'll demo from a certain different perspective. But we want to be able to do the same kind of numerical, quantitative methods against our infrastructure. So I think that's the onus is on all of us to start to understand what that could be from an infrastructure point of view, whether it's your configuration or whether it's your anything below the application. How do I make it repeatable, testable? So I think Tectonic did this well in the terms of having 2 upgrades going on at once and rolling back, but how do I bring that to all my infrastructure pieces? And so in some ways, I'm trying to share this collective blame with everyone.
Right. So when I was working at Target, so a lot of people don't see Target as a tech company, but it is totally a tech company. And have thousands of application developers, all excited to be on Kubernetes. And the first thing we had, so we had a running Kubernetes cluster about 3 years ago. This was the first thing that took our cluster down. So if you put a star in your ingress somewhere, by mistake, maybe your regex didn't work or something, your Kubernetes cluster is going to forward all the traffic from all the cluster to your container. And so one container receives all the traffic of all the cluster. So this was the first one that took the cluster down. So I'm going to show you a lot of these things. And then when I was at Target, I authored KateGuard, which detects all of these bad things and finds out who did it, and they takes action on them. Nowadays, you could actually prevent a lot of these things by admission controllers. But these are the things that you need to be aware of. So, these are the bad things you could do. So a star in an ingress. Large image size. So told you guys, like Kubernetes is a scheduling system. So if you don't want to be scheduled, do not be on Kubernetes. Like you can just run your VM, it's okay. It doesn't have to be shiny. Like if you do not want to be moved around at any second, why do you bother? Like so if you deploy say 100 images and each of them is 15 gigabytes and then do a kubectl get pods, your response is going to be maybe 5 seconds. But if it's like 46 megabytes, your response is going to be milliseconds. It's so fast. And when you accumulate thousands of developers, each one deploying a 5 or 15 gigabyte image, is going to slow it down. And you have no idea how easy, I mean, you probably have idea, I'm sorry, how easy it is to convert a big image to a small image. Use the builder pattern to build your images in Dockerfile using a multi-stage. So just build whatever you want, use all the JDK, all the fancy things, and then copy the last jar or the last binary to your container from scratch. And this is not only a performance issue or a stability issue, it's also a security issue. Because the larger your image size is, the more tool you ship with your application, the more is the attack surface. The more security problems you're may not be aware of. So just copy what you really need. And remember, you are aiming to be scheduled, like moving around from this cluster to that cluster. That's the best. You're playing Tetris. You don't want to send a big shape that doesn't fit in anywhere. You want a small shape. The the smaller the better. Another thing that took our cluster down was an externally hosted image. This happened in prod. And I'm sure you have seen it. Probably a lot of people still do. In your deployments, use the image hosted on Docker Hub, like just say Nginx. Terrible, terrible idea. Terrible idea. Because Docker Hub is open source, free service, unless you pay them. They might rate limit you. And also, the image might get deleted. And also, the image might get compromised. So do yourself a favor, get some Docker register yourself. GCRs are super cheap. Anything is super cheap to host it yourself. So you're deploying to prod. Docker Hub is not there for you. What are you going to do? This happened and took our cluster down. Privileged containers. This one did not take our cluster down, but it's compromised our security. Anybody here knows about the security? How many people know about the problems of privileged containers? Okay, one. Anybody else? 2, 3, 4. Okay, that's a good amount. So when you run a container as the privileged mode, which you can, by default it's not privileged mode. The bad thing that can happen, it means your container can read other containers' namespaces. So one container can go read everybody else's processes and memory space. Not only can be a security problem, it also could, by mistake, step on another process's foot and take it down. So unless you really need it, you should not use privileged mode. Some people just say, just give all the permission it needs. Do not. This one is very easy to prevent because you just have to not do it because by default it's not privileged mode. So if you see somebody is doing privileged mode in your developers, ask them, do you really need it? I've seen plenty of examples that people thought they needed it, but they talked them into not having it. This one, it can be easily prevented. Root containers. What's the difference of root containers and privileged mode? So if you run a Docker on your computer, let's say your username is Medya on your laptop, and you run the Docker as Medya. And then you have a script there running, let's say Nginx, and then you mount a file from your laptop that is owned by root to the container. Do you think the container has the permission to write on that file? How many people say yes? One? Just one? Wow. So it does have permission. Yes, you're right. So even though you're running Docker as Medya, not as root, you are mounting a root file system to your Docker container. And guess what? You can. Because Docker checks for user ID, not username. And user ID for root is 0. And you can easily do that. And no, I don't know how people don't know about it. It's extremely dangerous. Do not run your containers as root. How do you prevent it? Easy. Go to your Docker file, add one line, just one line. That's all you do. User ID and then something. Just name it whatever user. By default, all the Dockers run as root. And the root's user ID is 0. This can be easily prevented. I don't know why people are not freaking out about this. Each time I see it, it's super dangerous. Just try it on your laptop. Do not do this. Another one. Okay, so this one is very interesting. Because when we started Kubernetes Target, nobody was writing anything to containers because at the beginning, we do not really have volumes, but some people start having volumes in Kubernetes, which is okay. But there's one type of volume which should be avoided completely. The official docs on Kubernetes website says 99% of the time you do not need to do this. So if you see somebody mounting a host path volume, it means they are mounting a folder on the master of the Kubernetes cluster to their container. You should be asking yourself why they are doing that. There is only one use case for that. And that use case is when you need to change the Docker socket because you think Docker is doing something wrong. In that case, it's an extremely low amount of time that you really actually need to do that. But I have seen developers that, because they were lazy, they didn't want to create a volume. They just mounted the host path volume, the Kubernetes master clusters file system to their container and do their things there, whatever they were doing. And that's bad because they can step on each other's foot, two different containers. They can take down the cluster. This did take our cluster down. This is one of the items that the tool I wrote, which is open source, KCard, takes care of too. Did somebody ask a question?
Yeah.
Yeah.
On host path, sockets from container to container, and it's what is used to communicate with drivers for the storage system.
Yeah.
So not just the Docker, but also gRPC sockets.
Yeah, yeah, and there's other workarounds that you could use for sockets, but yeah, but this would be the danger path to good. Okay, I think this is the one that, I think this is the most common one that I've seen my entire life that takes on a cluster. I never seen anything else in entire time I've worked with Kubernetes that takes on a cluster than this. So let's say you have a cron job. It's very common to have a cron job. It's a type in Kubernetes, and the cron job, let's say, fails, right? And let's say that cron job is scheduled to be run every minute. In 3 days, one failing cron job by default creates 4,320 restarting pods. It means it creates 4,300 pods that are constantly restarting. Why? Because the default concurrency policy in Kubernetes for cron job is always run it in concurrent. You should, if you deploy a cron job, I wish that Kubernetes had a better default because this happens so much. When your cron job fails, which sometimes happens, for example, it tries to write something to the database and database is not there, it restarts, and the next job comes, the next job should replace the previous job. It should not have two jobs and two jobs are restarting forever, and then over time becomes 4,000 pods. So this problem not was only take the cluster down, it costs a lot of money because it was on auto scaling. And guess how many CPUs this cluster that I was looking at had by the time the 4,000, anybody want to have a guess how many CPUs it had? It was a small cluster. At the beginning, it had, I think, 4 cores or something like that.
So 1,000?
Well, close. It was about a few hundred. I don't know at the top of my head, a few hundreds of virtual CPUs are attached to this cluster. And you can easily prevent that from happening. Please do that. When you deploy a cron job, just make sure the concurrence policy is replaced or forbid. The default is terrible because all the failing one accumulate and all restart at the same time. Another thing you could do is when you live in the Kubernetes ecosystem, you should learn how to crash like a pro. Because Kubernetes, unless you use an init container, let's say you have a pod of 3 containers, and one of them is waiting for the other one or waiting for a database, whatever. When it fails, Kubernetes restarts it. That's what Kubernetes does. You should have used the capabilities in Kubernetes such as readiness check and liveliness check. These two things make you crash like a pro. So here's how I crash in my sample application. So let's say I want to connect to the database. Thank you for laughing. and my database is not there, okay? And what do? Do I want to just fail and let Kubernetes restart me? I could do that. If I do that, it will keep restarting, and Kubernetes will keep trying to talk to the database. Or I could have an exponential backoff. Say, try up to 5 minutes, or I don't know how many, 40 seconds, and then crash. That way you prevent, let's say the database is not there for 5 seconds. When you keep restarting and keep hitting it, you're going to make it down even worse. You just let it for, give it 5 seconds, okay? It will come back. So learning how to crash in Kubernetes is going to save you downtime in your Kubernetes cluster. This is the most common one I've seen. The bonus one, and the last one, I admit this is a controversial one because I've argued a lot of people about this, and this is my opinion. And some people deploy a container with only one replica in their deployment set. So when you deploy, I think you should deploy with 2 replica sets at least. You should never deploy anything with 1 replica set. Because if you are deploying with 1 replica set, it means your application cannot run in parallel. If it cannot run in parallel, you want to ask yourself why. Why it cannot run in parallel? Is it writing something to the disk, which you should not be doing in Kubernetes world? Is it, what is the reason? So, but some people tell me, no, I know what I'm doing. Okay, but this is my opinion. I think about it. If your application has to run in only one replica and cannot run in parallel, there's a big chance you're not ready for Kubernetes. If you want to learn more about these principles that I agree with, it's called 12-factor app design. You probably heard about it, but the colored ones are the ones that I like most. The config should be environment variable. The stateless process, it means the process should not write anything to the disk, or it should not, if you restart or shoot the container in the head in any moment, it should come back without any pain or losing any data. It should be stateless. And logs should never be written to the disk. And then concurrency, which should be able to run in parallel because you want to have highly available traffic. And then I have some time left for Eric to show us a cool demo.
3 minutes, Eric. 3 minutes. I'll keep it on point. All right, so in actuality, there's a lot of things I can show. But one thing that I thought would be the most illustrative is if I just narrow in on something that's more visual and show WordPress. And so it could be any application, and I think Medya's points would apply here, is really that what I want to show is how things can be a lot easier if we just start challenging the status quo. And so what this is 2 clusters in EKS. And we're uploading simple images into the EKS cluster. But what we can start to do with the EKS cluster is start to migrate the volumes. Because in all ways, we want a multi-cloud portable world because we were promised that kind of portability. So what we end up doing in this demo is really the fact that we have 2 EKS clusters that can be across AZs. There's low latency, and I'm trying to protect myself and start to create what starts to look like a stretch or a DR cluster. But the simple thing could be, how do I use it in a Kubernetes context? How do I pair those clusters? How do I run that application, manage the statefulness, and push it across? And so all I've done is take a WordPress container, add some images to it, and then start to do things like applying the applications and migrating the volumes. So here what we've done is we've actually migrated the data, and we can see it, and then now we're going to recreate on the second cluster. And this is all trying to illustrate some of the points I was making at the beginning, which is how do I make it so that there's backups? How do I make it so things are repeatable? And how do I make things that in some ways aren't reliant on a single point of failure? So what ends up happening here is we have to wait a few minutes, and that's in some ways why I recorded it. But you're waiting a few minutes, and it's actually rerunning the Kubernetes deployments for the pods. We're looking at WordPress, and we're now going to go get the service because I have to go publish or create an external load balancer in Amazon. I go and get the URL, and now I can go launch into that application and see the same set of content. So in some ways, what I'm trying to showcase here is the idea of I had a Kubernetes cluster with WordPress, I write all the data, I have a backup strategy, I keep it across, or I make it so it's multi-AZ, and now I can rely on infrastructure or other plumbing to start to create migration patterns or DR patterns, if you will. And moving the data, all I have to then do is substitute the PVCs, rerun it, and then I have my application with the data intact. So this is in some ways what I think we are all trying to push for as a collective community. I realized that was super fast, trying to keep within the time. Happy to stay afterwards, and Medya and I will be here for quite some time. So thank you all.
Thank you.